This is the screencast for section 2.1, example 1, power functions with modeling. Well, what is a power function? A power function is a function that has a constant out in front, or we call it a coefficient, and then times x to the exponent of anything non-zero. Specifically, if the exponent, we're nicknaming a here, is greater than 0, so positive, it is a direct variation. If the exponent is less than 0, that is an inverse variation. And a couple examples down here. Here are your direct variations. And here are your inverse variations, because these are negative exponents versus positive exponents. Example 1, writing a power function formula. From empirical evidence and the laws of physics, it has been found that the period of time t for the full swing of a pendulum varies as the square root of the pendulum's length, L. Okay, so it says varies. It doesn't say directly, but when it just says varies, you can assume that it implies directly. So let's start over again, because that sounded like a mathematical equation that I'm supposed to write. From empirical evidence and the laws of physics, it has been found that the period of time, t, for the full swing of a pendulum varies, so equals some k times, the square root of the pendulum's length, L. So k times L to the 1/2 power. I know that a square root is 1/2 power. Provided that the swing is small relative to the length of the pendulum. Express this relationship as a power function. Well, I just did. There it is. I don't know what k's value is. I do know that it's there, though. Until I know an actual L and t value that I can plug in, so like an xy that I could plug in for L and t and solve for k. K is just an unknown constant right now, but t varies, so equals a constant times L to the, well, the root, square root, which is 1/2 power of L. The now try problem, number 17, says write the statement as a power function equation, use k for the constant of variation if 1 is not given. So the area A of an equilateral triangle varies directly. So there it tells you varies directly. So A equals k times, as the square of the length s of its sides. So s squared. And that would be it. So until I know the side squared and then the area to solve for k, I wouldn't be able to figure out what k is, and it just remains an unknown constant.